Okay. All right. Thank you very much, everyone, for attending the Master C# 9 webinar. So my goal is to basically share with you all the latest features that are added to the C# 9 language and make you a master developer. So the agenda is basically starting with sharing a bit more about who I am, then talking about the state of C# and .NET, and then getting deep dive into all the features that will be added in C# 9 that will be released in November 2020. And then I will give you an overview of the Productive C# membership to understand, how to go even deeper on the topic and get support. And then we can do a Q&A session at the end, where I can answer any of your questions. Just forgot to say, if you can turn off distraction and fully focus on the content, as I have a lot of slides, a lot of material, so better if you concentrate and avoid distraction on emails and phone and stuff like that. Thanks. Right, so who I am. So I'm Andrea, I'm Italian. I've been working in UK since 2010. I've been awarded as Microsoft Most Valuable Professional 3 years ago. So I received the award for 3 years in a row for developer technologies. And that's a picture of me, the Microsoft campus in Redmond. I'm working full time in Reggae Software in Cambridge, UK as a senior .NET engineer now for about 6 years. And basically working on different products, all about database development, all in C# and .NET. Most of the products are using these technologies. So I've been working with .NET since the first version was released at the time when I was at university. And I've been founded and running .NET communities for more than 12 years now. I've created a community in Italy first, and now I'm running the .NET Cambridge community in Cambridge, UK. And we have now more than 1,000 members, and is a .NET Foundation supported community. And you're welcome to join. Now, considering all the situation at the moment, all our sessions are remote, so you can join us if you want. And on the top right, you can see the Productive C# logo. That's basically my brand, the blog I created, and all the platform, the Productive C# platform that I'm going to share with you a bit later in the webinar. Please try to stay till the end. I have some amazing offer for you and bonus at the end of the session. And obviously, I can answer any question you have about Productive C#. I've been focusing on this for about 2 years now, and we've grown a lot since the beginning. All right, so let's get into the content. So what's the state of C# and .NET now in 2020? So the strategy of the language hasn't changed since 2017. This is 4 key points for keep C# growing. As you might know, C# is starting to become quite an old language. It's 20 years old now, but is really it never stopped evolving, and it's always been at the cutting edge of the field. In fact, Microsoft is really committed into helping C# growing and evolving, based on the needs of developers now, the cloud and all of the current trends. So they want to innovate aggressively, but at the same time trying to preserve the essence of the language that is, simple, easy to understand language, very readable, and a pleasure to work with, to be honest. So they want to keep that while innovating aggressively, and they try to innovate in a way that benefit all the developers. So they are adding, especially recently, a lot of low-level features in the language in a way, however, that impact everyone in terms of performance of the framework that C# is running on. But you can easily ignore some of these features. So Microsoft tried to add features to help everyone. Obviously, you probably know C# is open source. You can basically read online on GitHub all the design meetings that Microsoft does with all the decisions they make every week. It's actually quite an interesting read. But Microsoft still kind of keep a strong stewardship of design decisions. So they welcome input, but they at the end decide what's the future of C# to preserve the language and make sure that it's growing and becoming even more popular. So that's the strategy that's been set in 2017 to make it clear that C# is de facto the key language for running .NET applications. In fact, C# is ranked in the top 5 programming languages in the world. Different indexes varies. It's not too important, but the TOB index is like 5, the 5th language. According to GitHub, it's the number 4, but it's definitely one of the top key languages, despite it's been 20 years old already. So it's definitely strong and kicking. Even interestingly, the .NET Core framework, that is the runtime but C# use for running the code, is the most loved framework according to the Stack Overflow developer survey. And also ASP.NET Core, that is the Microsoft Web Framework, is also the most loved framework. So it's actually quite amazing to see such a strong interest for the framework by the community and all the developers worldwide. In fact, .NET now has been adopted by 5 million developers, and there is more than 1 million new developers in the last year that's been added. So Microsoft is really pushing strong .NET, and they want to make .NET kind of the single platform for building any apps. So that's the future of .NET. So .NET 5 is going to be released in November 10 this year, and is basically the future of .NET. I'm going to talk a little bit about this before we get into the details of C#. But the idea, is to have a single framework for building any sort of applications: desktop, web, cloud, mobile, gaming, IoT, AI, and trying to converge all of the different flavors of .NET that we had in the recent years into a single framework where Microsoft is going to invest everything in. And that's .NET 5. So let me talk a little bit more about this. So you know that .NET Framework, that's how it's all started, is part of Windows. And Microsoft doesn't plan to evolve the .NET Framework anymore. So .NET Framework 4.8 is going to be the last version of the framework. It's going to live forever as far as Windows will live, but it's the end of the road for .NET Framework. Microsoft will probably add like any security patches, anything like that, but all the innovation is going to be in .NET 5. .NET Core 3.1 will be effectively, the next version will be .NET 5. So .NET 5 is effectively .NET Core vNext. And it would be very confusing if Microsoft decided to call it .NET Core 4, because also we have .NET Framework 4 and people will be extremely confused. So Microsoft decided to call it .NET 5 and even remove the core from the name because it doesn't make any sense. In the future, it's going to be just .NET. There will be only a single framework. It's going to take a few years before that will happen, but that's the goal. And the same for .NET Standard. The .NET Standard was introduced in order to create libraries that could be consumed by different versions of the frameworks, by different runtimes. But in the futures going forward, there won't be any need for .NET Standard. It will be just a single framework. So effectively, you can see .NET 5 also as the evolution of .NET Standard 2.1. So .NET Standard 2.1 is going to be the last version of .NET Standard. In the future, you will create .NET 5 libraries, and this library can be consumed by any future version of .NET. And any new application, starting from November, actually from now, because it's already been released as a release candidate with the production, ability to use in production, .NET 5 is the future where the framework you probably should target if you build new applications, unless you are constrained by the environment. The first release, as I said, will be November 2020. In November 2021, there will be .NET 6, and so on. Every year, Microsoft now is going to release .NET. So they made the cadence of releases to be a lot more predictable. Every year in November, they're going to release a new version of .NET with a new version of C# as well alongside it. And every 2 years, they will release a long-term supported version. So .NET 5, .NET 6 is going to be the first release that is with a long-term support. .NET 5 is effectively the starting point of the evolution of .NET, of a single unified framework. There's a lot of stuff new in .NET 5. I'm not going to get into the details because this webinar specifically on C#, but I want to cover very, very briefly some of the key and exciting things .NET 5 brings to the table. So as I said, a unified .NET SDK experience, single base class library, so you don't need to worry about anymore about different runtimes. Cross-platform support, run on Windows, Linux, Mac OS, and so on. There's also ARM64 support. They made a lot of work to improve performance and make the footprint of the framework as small as possible, so you can use it in containers or as part of a microservice application. Cloud native support, and they've done a lot of investment in trying to make the experience of building microservices and easier using the project type. Quite an exciting project to keep an eye on. Still early days. There is support for WebAssembly binary formats that will be heavily used by Blazor, the way to build web applications using C#. That's also extremely exciting for a C# developer. Something very interesting is the ability to deploy your application as a single exe. As you know, in .NET, .NET is all been coupled with Windows, and you had to rely on the .NET framework on the machine to be able to run your application. Now you can embed the .NET framework itself as part of your application and deploy it as a single application. Of course, the size of your executable is going to be bigger, but you can use another feature that's called assembly trimming that is going to basically remove everything that is not used from the framework to make your single exe very small and compact. So I expect that will become quite an interesting way of deploying .NET application in the future, and also allows the ability to have different version of the .NET framework, not the .NET framework anymore, .NET running on the same machine. In the past, that wasn't possible. You had to only have one framework running. Click once deployment is also supported. All the kind of Windows Form, WPF, all the things we love will be there. There is a lot of effort also in making consuming and creating REST and gRPC API easier in Visual Studio, and obviously C#9 that we love, F#5, and VB.NET unfortunately will be no longer evolved as a language. So C# is the bet from Microsoft for the future, and F#5 will be obviously F# will carry on as well. Cross-platform native UI is also another big thing. This probably will be coming later in 2020, and with a final release in .NET 6. The idea is to have a single cross-platform native UI experience. This is basically the future of Xamarin Forms that allows you to use .NET and build UI in different operating systems and mobile phones as well, using a single project. That's kind of the idea. That's called Project Maui, but it's still a lot of work that Microsoft need to do in order to make that happen. But that's very exciting. Also, cross-platform web UI is built on a core, very popular. You can run it everywhere. And deployment on Linux also is increased a lot recently. So .NET 5 brings a lot on the table, but the key thing is basically the unification of all different kind of runtimes into a single one that Microsoft will innovate aggressively on. Okay, so that's all about .NET 5, and as I said, it will be released in November 10 at the .NET Conf that I invite you to register for it. It's going to be interesting, and Max will share any news about future roadmaps as well. Okay, let's get started with C#9. So what do you need in order to get started? So C#9, as I said, is not, at the moment of the recording, is not being released yet. It will be released soon, November 10. You need to install Visual Studio Preview to be able to get access to the latest C#9 features and experiment with it. You need to install the .NET 5 SDK. At the moment, there is a release candidate 2, but at the time you're watching this video, probably .NET 5 has been released already. Just go to .NET/get.NET5 to get the SDK, install it on your machine, and then you're ready to go. You can create a project, target .NET 5, and you are basically ready to write C#9. So this an important difference in terms of the versioning of C#, starting from .NET 5. You don't need to specify the language property in your C# projects anymore, because if you target a particular version of the framework, there will be always a specific version of C# mapped to it. So if you target on .NET 5, the language version, default version is going to be C#9. If you target on .NET Core 3.x, it's going to be C#8, and so on. So the language version will be determined by the target framework. And C#9 is going to be supported from .NET 5, a newer version. So you're going to need to use .NET 5 to take advantage of all C#9 features. However, you can obviously still add the language tag, a property, and specify a particular version that you want. You can use preview to get all the latest, preview versions of C# latest to get all the latest version, and so on. You can specify the specific version as well, 9.0, for example. And that's it. That's basically how you can now already try it on C#9 on your machine. So I invite you to do so after the meeting if you haven't done it already, so you can play with all the things I'm going to share with you. Okay, let's start with one of the key features that has been added in C#9. So as you know, when you write a C# console application or any application, you need to create a class program, for example, with a static main method that basically is the entry point of your application. It's a bit of a boilerplate code that is a bit annoying, especially if you want to learn the language. If you start from learning a language, it's a bit annoying that you need to learn about what classes are, what's the static things is. It's a bit weird. Like if you play with Python, you can just immediately start writing the code and you will be able to use it. And that's something that Microsoft added in C#9. So you no longer need to write the class and the main. You can just start immediately writing system console write line, hello world in C#9, in a single line of code. You basically have an hello world in C#. And obviously, nothing happened under the covers. The C# compiler is creating the program and the main method for you under the covers. So what you can do with top-level statements. So you can access the arguments using args directly. You can use await, async and await. If you do, the frameworks is going to create, obviously, an async main. You can create functions and use variables that are, present in the code directly in the function, and Microsoft will translate that in a way that it will be accessible to the functions. You can even declare classes directly inside the top-level statement. So that means from now on, you can just write the statements you need straight away in a single file to be able to play with C# in a console application. You can create even a web application directly in a single file without having to worry about the main. So that's quite handy. Next is another feature called Init-Only Properties. So C# always had the concept of properties that basically allows you to set and get values. However, there's a very useful syntax that is the object initializer that allows you to basically create a new object, for example, in this case, country, specify the name of the property equals the value, and that's very readable. Unfortunately, if you want to make your class immutable, you can't use object initializers because those object initializers require the properties to be settable, and we don't really like making properties settable. We usually like immutable objects, and to avoid changing the properties after the object has been created. So in order to use object initializer before C#9, you couldn't do it. You had to expose the class and all the properties. So now with the init-only properties, you can add instead of using set when you create a property, you can use init. And now you can use the object initializer syntax to initialize an object, but still have the immutability, meaning the properties are still immutable, so you can't change them after the object has been created, but you can use the object initializer syntax to create the object. So that's a quite useful feature, and it's been added also for supporting the biggest feature of C#9, that is records. I'm going to talk now. Okay, so in the past few years, like there's been a trend of wanting to create immutable objects that have a value type semantics for plenty of reasons, like to make your object more encapsulated, improvement in terms of threading and so on. But in C#, creating a value, an object that is immutable and also have value type semantics, value object semantics, meaning two objects are the same if all the members are the same, is quite tedious. It's always been very tedious. You can see on the left-hand side that in this, the code is defining a book class with three properties, name, pages, and language, with a constructor that takes these three values, a copy constructor that's copy the values from another book, get code in order to be able to use the object as a key in a dictionary, equals methods that implements IEquatable T interface in order to be able to compare the two objects, operators equals and different equals, toString to represent the object, and a deconstructor to take an object and decompose it into its own components. All of that needed to happen every single time you need an object, a value object, a class that basically is a value object. There are tools like Resharper or Rider that help you to create this sort of boilerplate code. Even Visual Studio helps with that, but it's code that you need to maintain and makes the code very verbose. And to be honest, that's something always annoyed me about C#, not having a simple way to do this sort of things. So the good news, and I'm very excited about that, is that now you can do all of that in a single line of code by using the record keyword. So you can say public record book, specify as you would do normally for a method, the type and the name of the properties, and that's it. You created a record book with a name, pages, and language, and under the covers, Microsoft create all of the code for you in order to handle immutability and equality. Let's have a look on the code that Microsoft create. You don't have to understand all of this code, just to give you an idea of what's in there. And also I want to focus you on a few things that are interesting. So obviously it's generating all the properties, the constructor for you. There is on the bottom left, you can see there's an equality contract. It's actually quite interesting. It's a protected virtual method that should trigger in you the question, oh, that's interesting. If it's protected virtual, it means that records probably should support inheritance. Yeah, in fact, yes, that's true. Microsoft had the support for inheritance in records, and that's why this method are protected virtual, because it allows you to change the behavior of records if you really want to customize a bit how the generated code will be. But the idea of the equality contract is that if you have records in a hierarchies, two records that are of different type will be different by default. If you have a book and a special book that inherits from book, if you compare two instances of the different records in the same in the hierarchy, they will be different. So they must be of the same type to be equals. Microsoft also implemented toString and have a protective virtual method print members that allows you to customize how members are printed if you don't like the default toString method. It's also protected virtual because it allows you to combine all the properties from all the records in the hierarchy. As you can see on the bottom left, in the equals method that is automatically generated by the compiler, there is an equality between the equality contracts that you can change, of course, if you want. There is also a clone method, also virtual, allows you to clone a record by copying all of the properties into the new one. And I'm going to go into that in a second. So there is this with expression that is a new addition to the language. When you create immutable objects and you want to create a new object that is similar to another one, it's always been very tedious to do that because you had to basically copy all the properties one by one in the new object. If you have like a record with a lot of fields and you only need to change one or two of them, it was a bit tedious. So now you can use the with expression to do that. So yeah, I have a book here. And I can say, I want a book with language equals English, for example. So now English book is going to be a completely new instance of a record type with just all the properties from book, but with language and pages changed. As you can see, when you do toString on it, you get this representation. Let's show the name is C#, pages is 10, and language is English. So very handy with expression, allows you to easily clone records and make slight changes to the properties using the object initializer syntax. Under the covers, the compiler is basically calling the clone method that I've shown you here on the top right to actually create a copy for you, and then allows you to set the properties using the object initializer. So very useful if you work with records. Well, as you probably noticed, what we created before was a positional record, meaning in order to create an instance of a record, you basically had to specify the parameters on a constructor, right? You were not able to use the object initializer syntax to do that. If you like that and you want to use the object initializer syntax, you can use named records. Basically, you do not provide the parameters, immediately at in the line where you define the record, but you use init-only properties, and then basically you have immutability because the init-only properties provide that, and you have the object initializer syntax as well that you can use. And then what if you want a mix of the two? You can do that. You can add obviously stuff to the records. It's not that all the code is generated by Microsoft. You can still add your own constructors that call the constructor that is automatically created by Microsoft. You can add your own methods and everything you're used to. So in this example, for example, you can use you can create a book passing all the 3 values directly because there is an automatic constructor that is created by Microsoft. Then you can create a book only passing the name, and it's going to use the first line, the first constructor that we specified that is delegating to this constructor. You have to delegate to this constructor, otherwise Microsoft will not compile this code. And the last example is basically creating a book passing 2 properties, but not passing the language, for example, by using the object initializing syntax to pass the language. So you have a bit of flexibility. Honestly, I believe probably most of the time when you create a record, you're going to use the positional records. So you're just doing a single line, and you just rely on the only constructor that Microsoft provides for you. So records is really an exciting feature. To be honest, it is the #1 feature added in C#9. Finally, you don't need to create a lot of boilerplate code when you want value objects in your code, and they are extremely popular, especially for storing data as DTOs, for example, that need to transit on the network and stuff like that. Using the JSON serialization also now will support records as well in .NET 5. So definitely is going to be massively used feature in C#9 projects. And as I said, there is inheritance support. You can create another record that implements a record, and this is the syntax to do so, fairly obviously. And Microsoft is generating all the boilerplate code for you, and the behavior is going to be pretty much as you expect. So if you compare a book with a special book, they're obviously going to be different. But if you compare 2 special books, they will be equals if all of the 3 properties will be the same. If you compare 2 books, they will be equals if only the 2 properties, name and pages, will be equals. So all the kind of obvious implementation behaviors will be there. But because this is code that the compiler generates, it's always nice to test and make sure that it behaves like you expect. And personally, I don't know if I will use inheritance a lot. I will probably try not to avoid inheritance in general. It's just a general design principle to try to favor composition over inheritance. But it's nice that the C# team implemented the records in an object-oriented way. In fact, C# is an object-oriented language, and I believe this was the reason why they haven't implemented records until now. They really wanted to do it right in an object-oriented way, and that's possible today with C#9. Right, so let's have a look at all the other tons features that's been added in C#. One of them is the target-typed conditional expression. So if you have a method, for example, that returns a shape and you want to return a square or a circle based on a particular condition, and square and circle are two classes that implement shape, unfortunately, the compiler wasn't smart enough to understand that both square and circle can obviously be assigned to a shape, but you had to explicitly add a cast. That was very, very annoying. And in C#9, this is no longer a problem because target type conditional expression feature is present, and the compiler does what you would expect. So you don't even notice that this feature is it's been added. But it's useful because you're going to remove cast around your code. And we don't like cast, right? Another feature that helps you to remove unnecessary cast is the covariant returns. So on the left-hand side, you can see this is code written using C#8. I have two factories to create shapes. One is a shape factory, and another one is a squared factory to implement the shape factory. I really, really would like create in the squared factory to return a square, because I know the squared factory returns a square. But unfortunately, I can't in C#8, because if you have a public virtual method and you want to override it in another class, you have to use the same types as a return type. So that means when you call the shape factory, that is you call the shape factory, and the shape factory is a squared factory, you need to cast it into a square. It's very annoying. And this code actually has been present in the C# compiler itself that is written in C#. And they have a lot of this cast all around their code bases. And with C#9, they managed to fix this problem by, let me show you the code. Oh, there you go. On the right-hand side, you can see that now you can return square directly in the squared factory without getting a compilation error. So that means the client doesn't need to do any casting. You can just call shape factory create, and automatically will be a square. As you can see, I can access the size property directly that is only present in the square class without any cast. Small features, but really nice if you tend to use this sort of patterns and you have cast all around your code base. Next is the ability to extend for each loops. So up until now, if you wanted to use for each on an object, the object had to could implement high enumerable, or could just expose a GetEnumerator method in the class itself. But you needed to change the actual class to be able to add support to it. Now, Microsoft extended relaxed the constraints, giving you the ability to provide an enumerator as an extension method. So for example, in this code, I have a tuple class with the 3 values that obviously doesn't support for each. Microsoft didn't have the support to for each for tuples. But if I define an extension method GetEnumerator on a value tuple with 3 parameters, and I just return the 3 values, all of a sudden, the for each will be able to iterate over a tuple. So that means with this feature, you can take any code, any class in any libraries, add an extension method, and make that iterable using for each. With great powers comes great responsibility, but it's something that could be useful in some situation. There were some situation where this feature is useful. Then there are 2 interesting new features that relax some of the constraints with C#9 in terms of extensibility. Let me share with you. One of them is the partial methods. So up until C#8, partial methods were extremely limited. So you could have partial classes in different files. Very useful. We've used them all the time, especially Windows Forms or any other kind of tools that automatically create code behind, was using partial classes to separate the code that you own from the code that the framework automatically generates. And partial methods were basically a way to extend, to add some implementation on code that was automatically generated. But the limitation were that the partial method must be private and void, return void, and obviously it was a bit limiting, right? So you couldn't use out keywords, you couldn't return values, you couldn't make it public or anything like that. The main reason why Microsoft had that limitation was because they wanted to provide the ability to automatically remove a call to a partial method if there was no implementation. Because the method was void and private, there was no this wasn't a problem. However, C# 9 now added support for using this accessibility on partial methods, using any return types, using how parameters, pretty much everything you can do with methods, you can do it with partial methods. There's only one limitation, that is obviously if you use an explicit accessibility, you need to have a definition. So there must be an implementation of the partial method for the code to compile. Before, if there was no implementation, the compiler would just simply remove the call to the partial method. Now, if you're using if you have explicit accessibility, if you make it public, for example, this is no longer the case. You always have to have an implementation present to have the code to compile. Especially if it's returning values, you might actually using this value in the code base. There's no easy way to remove a partial method call from the code. So this is kind of extend the possibilities that you have for extending, partial classes. Another features that also allows to do something that wasn't possible before is called module initializers. So module initializers allows you to run code at the beginning of any time an assembly has been loaded in memory, before anything else, even before static constructors and static initialization. The way to do that is fairly simple. You need to use the system runtime compiler services namespace and decorate a static void method using the module initializer attribute. You can have as many as you want. They will be called in a deterministic way, but you can control the order of the initializers. And you can imagine this can be fairly handy. I'm going to tell you the key driver why Microsoft added these two features, partial methods and extensions and module initializers. There are obviously the same limitation as there were with the partial methods for initializer. They must be static, no parameters, no return types, no the method must not be generic, and obviously must be accessible in the module, so need to be an internal or public. And as you can see on the bottom, you can see that the initializer 1 and 2 are called one after the other, and then the console write line is being called. This is something that the runtime always supported, but wasn't exposed in C# in any way. So the main reason why these two features has been added is to support metaprogramming with C# code generators. So this is something quite exciting that Microsoft is adding. It's not a C# feature itself, it's a compiler feature. Compilers will allow you to create a code generator that will run at compile time, and the output of a code generator is obviously code, C# code that will be generated in a file. And obviously you can use partial methods, you can use partial classes, you can use object initializers, and this code will be added to your project at compile time. And you can actually see that code in Visual Studio as if it was normal code that you wrote, but in reality has been written by a code generator. You reference code generators using NuGet as you would normally do. You create them, as libraries, and you publish them on NuGet. And they work fairly similar to Rosalind analyzers, but the goal is not to produce any kind of diagnostic. The goal is generate C# source code at compile time. So this diagram kind of explains how they work. You have a project, you build it, the source generators will analyze the source code, will provide you all of the syntax, abstract syntax tree of your whole project. You will be able to generate your source code that will be added to the compilation and will be compiled as normally as as obviously any single generators will follow the same process. Depends on how many you added in it. There is no way to edit existing code. You can only add new code, and that was by design to avoid making the C# compiling too complicated. And that's how source generator works. There's a link there that explains how you can try that. It's currently in preview, but it's actually quite an interesting feature that enable metaprogramming in C#. You can still do it. Up until now, you were able to do it using some third-party tools in some weird way, but metaprogramming now from C#9 is going to be supported, built in the compiler. So quite an exciting feature there. So I'm looking forward to see what kind of code generators the community will implement and Microsoft itself. Okay, so now let's move on into improvements that Microsoft made on patterns. So patterns has been added since C#7, and then C#8 introduced additional patterns, and Microsoft is carrying on adding, improving the patterns matching experience in C#. So this is a small one. You can have type as a pattern. So if you wanted to, for example, use a switch expression and you wanted to match on a type, you still have to give it a name. And if you don't use it you have to call it underscore, for example. But why? If you don't really need it, why do you need to add an underscore after the type? Yeah, there was no need for that. It was just a limitation of the compiler. This limitation now is not there anymore. You can just say square and then circle, and you don't need to specify an underscore. Just as well, it's more stuff that remove some annoying things in the code. Relational patterns are interesting. So if you want to do a switch statement, up until now you had to use a pattern, but there was no way to use like ranges to match particular variables. So you couldn't use a switch statement to do that. You had to do like using a series of if statements, for example. You can see like life stage at age, you give an age, and based on where the age lives, you return a particular string. Now with the relational patterns, you can simply do, use lower or lower than equals, greater or greater than equals, and you can actually immediately use a pattern in a switch expression or in an if statement without having to use the variable every single time. So this, I think, is quite useful. This is another pattern, the not pattern. So C# had the is operator that allows you to check if a reference is of a particular type and return a Boolean. There was no way to check if a reference was not of a particular type. So you had to like wrap the expression in a parenthesis and add a not before. So creating a little bit weird syntax. I never liked that. So likely Microsoft in C#9 added the ability to add is not to make sure that a particular reference type is not of a particular type. Small improvement. Let's make the code more readable. So I always welcome this sort of changes from Microsoft to make C# even more expressive. Then Microsoft also added patterns matching combinators. So if you can see on the top, is letter is implemented, as you would expect. However, you need to repeat the variable name every single time. C is greater than A, C is lower than Z, and so on. With matching combinators, you can use and or, and you don't need to repeat the variable name every single time. You can say C is, and then you can say greater than A and lower than Z. You can even use parentheses to specify, the order of matching, and you don't need to repeat the variable every single time. Obviously, this example is probably not the best. I'm not sure which of the two I like the most. With pattern matching, you need to understand that you need to always use common sense if the code is more readable or not. So I leave that to you to decide when the code is more readable or not. Another thing is that if you use a type pattern and you capture the variable and use the AND combinator, everything on the right will basically use the same type as the left hand side. So for example, you can see that his single digit here is doing O is int I, and then he's using I on the right of the expression. Now if you do O is int, you don't even need to specify the variable anymore. You can just simply use the combinators to do your check. You don't even need to create another name for the casted object, if you see what I mean. So again, slightly small improvements that might be more readable in some situations, especially in switch expression. I also haven't used this feature yet in production code, but I can imagine this feature to be particularly useful in switch expression, as I've shown you before with the relational patterns. But is also an addition to the language. Another things are lambda discard parameters. So if you wanted to create a lambda and you didn't care about the parameters, you still have to give a name to the parameters, and the name couldn't be the same. Like you tend to use underscore and 2 underscore and 3 underscore. It's a bit odd. So now you can just use underscore to ignore the parameter, and the compiler doesn't worry, about the fact that you specified the same variable name, because underscore is treated is in a special way. It's effectively a way to tell the compiler, I don't care, right? Small improvement there. Target typed new expressions. So in C#3, Microsoft added the var keyword as a way to avoid having to specify the type twice when you create an object. You can say, in order to create a school, you had to do something like school space school equals new school. That was a bit odd because you had to specify the type twice. With the var keyword, you didn't need to do that anymore. You could just say var school equals new school. Awesome feature. However, there were still some cases when you have to repeat the type, but just because the compiler is not smart enough to figure it out. For example, if you have a read-only a dictionary as a field in a class, there was no way to use the var keyword there because that var is only available for local variables. So you had to still create dictionary string of list of student and new, and use the same type again. With the new target type expression, that's no longer the case. It's kind of the opposite of var. You don't say var at the beginning because you can't, but you use new on the right-hand side to say, I want to create a new instance of this object using the default constructor, but I don't need to specify the type because I already told you on the left-hand side. So the compiler is smart enough to figure it out now. Same, for example, when you actually you want to pass an object to a method. The compiler already knows that the method is accepting a particular object. Why do I need to specify that? Sometimes you want to specify that because it's more readable, but you don't have to. In fact, for example, when you create a list of students, is another example. You're already telling that it's a list of students. Why do I need to say new student every single time? You just say new, right? So the compiler automatically figured out the type for you in these situations. So it's a feature that can remove some boilerplate code. Obviously, use it only if the type is explicitly visible in the code. In this case, perfectly makes perfect sense because student is very visible in the second line, and also in the field it's very clear that it's a dictionary. Sometimes this feature could make the type less visible, even if the compiler can see it. Doesn't mean that the developer can see it. So you always want to write a code, obviously, to optimize for readability from other engineers. So use this feature with care. Another addition is the ability to add attributes on local functions. It wasn't possible before. Now you can. For example, you can add the conditional attribute there, and it would work normally as other attributes. Static anonymous functions. That's an interesting one. When you write some code like the top one, I have an array of numbers. Then I do like classic link filtering and selection. You usually pass lambdas, anonymous lambdas, right, to these methods. However, you know that when you use this sort of anonymous lambdas, they always capture local variables. So Microsoft generates a little bit of code every single time to make sure that you can capture these variables, and that might not be as efficient as you want. Because most of the time, you don't really want to capture variables, right? So finally, now you can use the static keyword to say that you want a static anonymous function, and that means there will be no capturing of variables, and that means the calling the lambda will be faster, right? So it's mostly a performance improvement. So most of the time you probably don't need to care about this adding static, but if performance is important, you can just do that and slightly improve the performance of your application. Of course, always measure when you do performance improvements. Then let's move on to some low-level addition to the language. So up until now, all the types in C# always had a fixed size in terms of the size in memory. Integers were always particular size, floats and booleans and so on. Now from C#9, they added types whose size depend on the actual runtime where the code is running. They added native size integers, an int, and native unsigned integers, NuInt. As you can see from the code, if you use size off on an int or NuInt, you need to be using safe because the size off is not going to be a constant. It will depend on the runtime. So if I'm targeting x86, it's going to be 4 bytes. Otherwise, it's going to be 8 bytes if I'm targeting A64. So the size of the integer, of the native integer, it's going to be dependent on the platform where the code is running. And that's obviously very useful if you're using, if you do interrupt, and low-level libraries can take advantage of this new way of defining integers. And that's probably the main scenario. You are mostly not going to need to care about this. Low-level libraries will use these types, but you will probably expose the API in a way that you don't need to care about these types. Then there's another feature, another performance feature, that is the ability to suppress emitting the localsinit flag. So let me explain what that means. In C#, every time you create a new object on the stack, especially using stack alloc, there is always a 0 initialization. So all the values will be set to null or 0 automatically by the compiler, just for avoiding having random numbers. However, that can cause some performance issues, because what happens if you use stack alloc to alloc like 10 integers on the stack, and you will immediately afterward you use this memory for initializing with some custom initialization code. Why do you need to initialize it twice with all zeros and then with your own initialization code? That would cause some performance issues. So you can use an attribute called skip localsinit attribute on a method, and by doing so, you are basically telling the compiler to not do the runtime to not do any zero initialization for your memory. As you can see on the right hand side, basically whatever is in memory will be what's there. There will be no memory initialization in these situations. Obviously, something to use with care, probably only low-level libraries, but can help to improve performance if you need to do a lot of operations on the stack, mostly probably related to stack alloc and using span OT kind of things. And finally, I want to talk about function pointers. That might be a bit surprising for you, but they are coming to the language. It's basically the ability to use function pointers. Let me show you something first. So obviously, you know that we have actions and functions, basically delegates in C# to kind of represent the concept of function pointers. And they are used all over the places, right? In LINQ and any modern C# application use lambdas a lot, lambdas and delegates. As you can see in this example, I'm defining our f as a func that takes an integer and return an integer. And I'm using the method group to assign the method to the lambda. That means whenever I use f, is effectively going to call whatever method I associated to it. So if I call f10, it's going to return 100. Under the covers, when you invoke delegates, the underlying IL is going to use the call virtual code in order to actually invoke the delegate. However, there are scenarios when you need to invoke like some native functions where you want to take advantage of some different calling conventions to improve performance as well. So in that situation, you want to consider using function pointers instead. So the syntax is very similar to delegates. Basically, you use delegate star, and then you use the same syntax as you use for action and function to specify the parameters. So in this case, with delegate star int, I'm defining a function pointer to a method that takes an integer and return an integer. And then you use the ampersand to get the address of a particular method to assign it to the variable. But what happened under the covers, this is obviously unsafe code. What happened under the covers is the IL code that will be used is called I. That is obviously a different kind of calling convention and doesn't do any virtual stuff. So the code is more efficient when you use this. And then C# goes a bit crazy by providing the ability to specify explicitly what the calling convention is going to be when the function pointer is invoked. So by default, if you don't specify anything, it's going to be managed using the default kind of calling convention in the .NET framework. So delegate star managed is the same as delegate star. That's basically what I've shown you in the previous slide. However, you can make the function pointers unmanaged, and if you do that, it's going to change the calling convention based on the runtime where the code is running. Or you can specify in square brackets the specific calling convention that you want to call. And there are different calling conventions defined in the ECMA 355 standard, that is the Common Language Infrastructure standard, has been created since the beginning of .NET. Standard C or standard C++ or special optimized C++, or this call if you need to kind of use a function pointer to an instance method. So you can actually use this sort of low-level function pointers if you really need to interop with other code in a more unmanaged way. I mean, this is something you can probably safely ignore because you can always create an easy wrapper to never expose this sort of details from consumers of libraries. But this is stuff that Microsoft added to the language to provide a way for developers of libraries, that low-level libraries or frameworks, to really improve performance significantly or improve interoperability between different languages. In the future, .NET 6, I think there is plan to improve interoperability with other languages in the pipeline. And if you don't know about calling convention, that means how a method expects the arguments to be passed from the caller in the stack. So there are different ways of doing that. So you can actually specify how calling convention can be done in C#. So that kind of covers all of the C#9 features that will be added. You can read more information about all the various proposals to the C#9 spec at this URL. There is basically a very detailed specification of each of the features, but I basically covered them all. And also you can see the status of C# on this page in GitHub. That also share some of the upcoming features in C#10. At the moment, there's nothing super big in there, but Microsoft never stopped developing the language. They're already working on features that will be released in the next version of C#10. So we'll see what the future looks like. But there is a lot of stuff online if you go in the official .NET Roslyn website. On GitHub, all the design meetings are there. So if you want to stay on top of C#, that's the best way to do.